So can see the slides. I will start already. Okay. Okay, can. So here, same format as the previous few lessons. We are going to have 15 MCQs as well as 5 open-ended and then one database question. So in case for you all who are not sure, I don't know whether your school teachers have informed you guys, there will be one database question. There should be one, especially because you are pure chem students. There will be one database question where it is a question that maybe you're not very familiar with one, but they'll give you a context, a bit like comprehension. And it's a very, very long question that they will test you on knowledge one. Then they will link it to several different topics that you have learned before already in school. So that one is what they call database question. If you have time, then we go through that one. Yeah. Okay, but now we go through the MCQ first. So please feel free to read the question here and then either you can unmute and share your answer or you can check in the text box, then we will just do a quick debrief. Yeah. So question one here basically is a chromatography experiment of an ink. Okay, so water is added in the middle of this circle. So you should be able to see that this is actually your paper. Paper is like this. Okay, instead of the traditional, the long one, and then your solvent move one direction, this is circular one. Okay, and then another experiment is carried out with the same ink using the same apparatus also, but this one is the long one, the straight one. Okay, are you able to identify what is your A and what is your B? Yeah. I hope you know how to answer. Yeah. Yes, yes, Chloe, very good. Correct. So I think I will start to debrief. If let's say you all are still thinking, you can slowly think about the answer. Okay. So basically over here, right, they're just changing your traditional chromatography onto a round piece of paper. So they start by adding the water here. Okay, and then what's going to happen is that because it's round, right, the water is going to move outwards. So it's going to travel out this way, like radius, like radius, okay, so it's going to go out. Then whatever ink that is present in the center will also be separated out. So you can see here, if the inside one is the blue dye, this blue dye travel less with the water. And then the red dye is further out. This is going to be traveling more, travel further. Okay, so on the traditional chromatography paper, when water now moves upwards like this, I should expect the blue one to travel less. This one is the blue one, and this one will be the red one. Okay, so the correct answer will be red and blue. Okay, there shouldn't be purple because purple tells me that they are together. So then you were not able to split the blue and the red out. Yeah. Okay, answer here will be C. If any questions, feel free to either unmute and talk me or you want to type in the text box. I will do my best to reply. Yeah, I open my textbooks here so I can check and see. Okay, okay. I think one last thing to also, I will also debrief a little bit on each topic. So for this one, chromatography, always remember what is the concept that it uses to separate your mixtures. It is the solubility of your different substances inside the mixture. So if you, in this case, you're using water as a solvent, means over here, those that are soluble in water will move further. Those that are less soluble will move less. So especially it tells me that my red dye is the one that is more soluble. Then my blue dye is the one that is less soluble. Thus looking at the distance that they travel with the water. Yeah, it's a recap only. Hopefully it helps you all to refresh your memory a bit. Okay. Question 2, diagram below shows you the structure of a particular substance. Which of the following has this structure? Okay, so this one, chem bonding question to see whether you can get it. Oh, and if you have periodic table, it will be very, yeah. Wow, I want to heart attack already. First two answers I get so far, both answers not correct. What? We all want to try again. Okay, maybe you can first tell me what type of compound is this? Because as pure chem students, you all will have learned that you have ionic compounds, you have simple covalent, giant covalent, and metallic, right? I think in schools, maybe they never focus on macromolecules, so it's fine. One of these four. This type of structure, is it ionic, simple covalent, giant covalent, or metallic? It's not diamond or graphite. Yes, I agree. So Wendell is correct. This is not diamond or graphite. Okay, so B. Okay, okay, noted. Yes, it is B. Okay, so every time you all see this type of like very cute structure like this, right? Okay, this is usually ionic. Can So ionic structures have this type of ionic compounds have this type of structure. So how to tell the formula of an ionic substance is usually they are made up of a metal plus a non-metal. Okay, so in this case it's B lah, because this one is a metal, this one is a non-metal. So I'm gonna label it as M and N, metal, non-metal. Okay, for the other three, if you are able to recall, silicon dioxide, graphite, and diamond, all these are actually our giant covalent. So I'm just going to run for option A, C, D. All these are all giant covalent structures, which means they have a very wide pose. STRUCT. Okay, they have a network of atoms and bonds. Okay. For silicon dioxide and diamond, okay, both of them have a very similar structure called tetrahedral structure. It's also similar. They love to have this one atom, one, two, four other atoms in a tetrahedral structure. So refresh your memory again. Tetrahedral structure basically you just imagine there's a tripod and then a head. Imagine a tripod here, three bonds down and one up. This is your tetrahedral structure. Okay, for graphite, this one is hexagonal planes. So hexagonal. Okay, one carbon bonded to three others. So I'm going to try and actually get we'll have something like this, something and etc. etc. Okay. So every carbon will bond to three other carbon atoms. Okay, can so cube structure always remember cube usually is ionic. So please think of ionic. Yeah. Okay. Okay, question three. Okay, you have magnesium carbonate reacting with dilute nitric acid to produce magnesium nitrate, carbon dioxide, and water. Okay, so which option, shows the ionic equation for the reaction? So this question here combines your chemical formula chapter as well as your acid-base chapter. Yeah. Okay, can go ahead and give it a shot. See whether you can identify. I will give you a hint. It's solid. I think not a lot of students have learned solubility at the source. I have some students that not even test on salts by end of the year. I'm like, okay. Going says D, D, C. Okay. Anyway, if you have answer you want to share, please feel free to share. So can one, no need shy one. If you know everything already, you don't need to be in tuition one. Yeah. Okay. So the correct answer here is D. So even though two of you get it correct, but then I will still go through because I don't know if there could be other students that are just like watching the tutorial, but then I don't know, yeah. So it's just to go through in case anyone else is watching. So why Randall's answer is not correct is because C, right, this is what we call a fully balanced equation of um that's called a balanced chemical equation. Okay. So this one is the full one. It shows me everything. Whether my ions are spectator or non-spectator ions, everything is inside. Okay, but if I want the ionic equation, you have to remember to split your ions out. Okay, so all those AQ1, right, go and focus on them. Okay, and then go and split them up into their ions. So for HNO3, which is nitric acid, able to split it out into H plus as well as NO3 minus. Okay, and then since I have two of them, it's two H plus and two NO3 minus. So it's split out already. Okay, and then same thing for my magnesium nitrate. I will split up into Mg2 plus and then two nitrate ions. Then I just need to go and check where are the ones that are similar. Okay, basically before and after the reaction, no chemical change one. So I'm not using the color here. Very blue. Okay, you will notice that this one, the nitrate ions are the same. So we are able to remove them because these are known as our spectator ions. Multiply in the reaction, spectator, watch the show. Whatever that's in the then you will see into your new chemical, new ionic equation. So Mg2 is here, H plus is here, Mg2 plus, right answer is here. Okay, can I? Mole fraction. The following is numerically equal to the Avogadro's constant. So this one, mole chapter, since I have a request to go through mole chapter, this will be sure a bit first, then you're going to pick the correct answer. Okay, so Avogadro's constant is basically this thing known as 6.02 and 23, right? Okay, so this one can be referring to anything. It can be atoms, you can be referring to molecules, ions, electrons, whatever. Treat this thing as a big system. It's like saying 1,000 eggs or one stack of papers. In chemistry, we call it 1 mole of water. So this one is a okay, so which of the following is numerically equal? Means I want you to check which one here is exactly 1 mole. Uh, okay, let's see whether you know or not. Yeah, be very careful. The wording very important one in chemistry. Anyone want to guess? Or maybe I start going through. Okay, I will start from A first. A number of atoms in 1 mole of hydrogen gas. So I get a number of atoms in 1 mole of hydrogen gas. This 1 mole of pair of this H2. Okay, so if I want more of this, means I actually have 2 moles of hydrogen atoms because each of them, each of the molecule, I can split it into 2 atoms. Okay, so it's like saying you have five give an example, you have 5 pairs of red pens, means you have 10 pens, or 5 pair of chopsticks, means 10 sticks. Uh, Okay, so number of atoms is 2 moles, it's not 1.